And I think that's all. Seems like one thing I'm very happy about is people have been jumping at the answering questions of the Google groups and on the Slack channel, which is very useful. So thank you for all of you who have participated by answering questions. Uh, and I think in general, there were not that many critical questions this week related to the lab, and it seems like most people were able to complete it successfully. I think there was some confusion at some point, and we'll get into the details in the part of converting from a data frame to an RDD. But I think for the most part, people were able to follow the lab pretty well. So at this point, I would ask you if you have any questions or you're interested in us covering something in particular, please say it now. So we go from that. Otherwise, we will continue by reviewing the lab. All right, no questions.
Hi, Armando. I have a question.
Okay, yes.
Actually, if we go to there was one particular question where we were supposed to, yeah, the question exercise for, just a minute, let me, 4E, right? Where we were supposed to get average number of daily requests per host.
Okay.
Okay, there basically I faced one issue. When we get the results, I was getting a result as a float number, and I was trying to convert that to numeric, and all the time somehow, like whenever I was using commands like show or you select, it was showing me that is a data attribute error. I don't know why it was happening.
Let me see. I'm getting to the 4E here in my pad. Yes, so because it was rounding the numbers, and then you would have to take a ratio. And you say you were getting integers as opposed to floats?
I was getting floats, but
Yeah.
like that the float number of decimals was too big. So I was trying to round off, because if I look in terms of test, in the
Yes.
test is an integer. There's no float there basically. So I was trying to round that off.
Yeah,
When
it casts the float to an integer, yes.
Okay, so when I was trying to do that, it was not showing me as a data frame. So all the commands related to the data frame were not working there.
So did you have it as an RDD at that point, or how did you?
Initially, I started as a data frame itself.
Mm-hmm.
And when after that, like once I applied that transformation and then reapplied some select features and all, because I wanted to just keep 2 columns, day and average. And
Yeah.
then it was I was not able to execute commands like select or show on that data set.
Okay, so what I'm thinking is that you converted to an RDD, and then once you're an RDD, then select would not work. We can look at it in more detail after. Maybe I can go over the code in particular. I mean, it's hard to tell without looking at the code, but based on what you're mentioning now, it looks like that's what happened. That you transformed the data frame into an RDD, and then of course after that you cannot do much in terms of applying the data frame. You could go back to from an RDD to a data frame and then use that. But maybe if we go over the solution, that might shed some light over what the issue might have been.
Sure.
But yeah, let's see how the session goes, and then maybe that would help clarify. If that is not the case, then I can go look at your code. I think that would be
Okay.
the best option for now.
Sure.
All right, thank you.
Thank you.
So there was another notebook that was linked on the material, and this notebook was an introduction on data frames. If somebody has questions over that, otherwise I'll just quickly go over it, at least some of the highlights. So certainly data frames are based on RDDs, but the beauty is that you would have that sort of column store where then you can access each one of the columns by name, which before you with RDDs, I guess you could, but it's not so straightforward. And also, well, one of the other things that you have with the notebooks is that you can directly, the entry point for the Spark session and now is called Spark. So actually, you don't even have to initialize the session as it is specified here. But just by tapping Spark, it's already initialized for you. So that's one of the beauties of using notebooks, but at the same time, it could be risky if when you're really, when you go in and applying an actual, you are processing real data, and if you don't have defined your Spark session, you might run into trouble. But one of the advantages then is that you can read easily, for instance, a file that is in CSV format. For some reason, this is not. Let me just read this. So you could read files from several formats. You could run it. You can read directly from. So this works now. Yeah, that works. So you can read directly from the local file system, or in case of HDFS, you would read from HDFS or whatever storage you might have. So if we were to examine the content of this particular data frame, we see that it has certain columns. So it seems like I missed the header. I didn't read the header. So let's see, how do we read with the header?
You need to add an option.
Oh.
Header equal
Hello?
true. Yeah, Armando, there's an option. You need to add that option header dot true.
Yeah, header, dot header. And what else? I can't remember the syntax. That's what I was looking.
No, it's option.
Oh, yes. Option, and then.
And in the option you
header
do is equal.
Like this?
I think you do it equal.
Equal.
In the thing, yeah.
Equal true.
Yeah.
Data frame. Oh, this is before. This has to be on the read. Before you read, you convert it to data frame.
Yeah.
There we go. Option takes 3 arguments. Okay, so let's look at the documentation, what I'm missing. PySpark. So read. Why did I miss? Let me just search the syntax. If anybody knows the exact syntax, make sure that you just share it with everybody. In the meantime, we're gonna what is it? SQL read here. This is the one. It's taking some time. Oh, I think it's actually like
Yeah,
that.
it's option header, comma, true.
Yeah. Yeah. Okay. All right. So then now, yeah, we were able to pick up the header, which in this case is the first line of that file. But that's not the only way of creating or reading data frames. You could also create a data frame from the object row. And this object row is imported when we do this import here from PySpark SQL. And then notice that this particular field's ID and name will correspond to the column. So all these rows have the exact same structure or the exact same fields. And then we could, once we have in this case 1, 2, 3, 4 employees. So we are creating we're creating the department 1, which is a row that has an ID and a name. Employee 2, this is an example, would have first name, last name, email, and salary. And then this one here, department with employees, would be a row of notice that this particular employees is a collection or a list of rows. So it's somewhat and it's a structure within the row, or a row within the row. So we could, in principle, just create a data frame having a list of those rows, which are defined in the previous line. So this would be department with employees 1 and department with employees 2. And then we can use the Databricks display DF to see the contents of that data frame. But one of the advantages of using data frame is that you can do other things. You can union 2 data sets or 2 data frames. You can, for instance, do joins, do merge, and the sort of operations that you do using that you might be familiar from SQL. There's a particular API. Notice that I'm not writing the exact SQL syntax, but just accessing the data frame API. So this would be in a way equivalent to a SQL statement, but is just a way of accessing that particular syntax of putting one data frame and union it with other. But you could imagine you could also do joins or other sort of functions. And if you want to look at a reference, I recommend always going to the documentation, and particular the API. You can also write file. You can write to a file. So this union df is a particular data frame, and you can write that, in this case, to a Parquet file. So all you would need would be the location of that Parquet file, and directly write to it. And then similarly, you could just write back. So notice that we're writing here to a temporary. Oh, I didn't write that part. You can write it back from that location. And so to read Parquet file, all you have to specify, similar to when we did CSVs, is to specify that this is a Parquet file. Oh, what happened? Path doesn't exist. Oh, it's because I didn't run this one. Yeah, didn't run this one. I skip it. Anyway, I'm gonna skip it for now, so we go on the lab, unless there's a particular question that people might have. I imagine you guys run this this particular code before. But here it is anyway. But it's just a way of quickly showing some of the basic functionality of data frames that in some way you would have to to use in the lab. So maybe if we go into the lab, that might help solve some of the questions. So yeah, let's go into the lab. So this particular lab was focused on analyzing logs, so Apache logs. So these are text files that we would have first, of course, to parse, and then once those files, those logs are read into a data frame, then we can start performing operations on them. So I'm going to skip all this part because this is repetition of last time, doing all the imports necessary to run. And yeah, let me make sure I have it here. And so this particular file, you don't have to do any imports. It's simply it's already available there in Databricks, so you don't need to do any special imports or any of that. I'm just going over my other notebook, so make sure that I can follow. So at this point, if we examine the content of that data frame, it is just a text file. We have not parsed it. So it is what you would expect from a log file, and I think the contents are, or the meaning of each one of them is specified somewhere before. But basically, you would have the host, some timestamp, and what location it was accessing, and what sort of response did it get. Also here, so we would have the remote host, the log name, the username and remote user, the request status and bytes. So how would you parse that? In this case, you can write some regular expressions. In this case, all that is written for you, and I think we covered that last week, so I'm gonna pass that for now. But one of the first things that you want to make sure in general when studying data is make sure that you don't have null values, or at least that you understand what is the meaning of those null values. So there is a function, in this case, we have this base df, and we are selecting the column value, and we are checking what are the values that are null. In this case, this will return true or false from where we would filter. So that means that the rows for which the value is not null will be the only ones that would pass. Oh, sorry, that the value is null, the only ones that would pass this particular filter. So if we count, well, in fact, we get that we have 0 rows, which is good. But let's check all the other values. So then in here, what you're doing is an OR of similar operation where you're checking that the columns are not null. And then in fact, I think in this case, we find that there are some null values. So we would have to investigate a little bit more. And I think what happens is the way that the parsing was done. So we're missing. So then the proper regular expression is corrected here, and then after we do that, we properly obtain we remove all the null values, or at least account for them, making sure that we're parsing them properly. So I'm going to move a little bit faster here. Then we parse the timestamp. So in this case, the location of each one of the components of the timestamps is defined by the location is predefined. So you would know that in the first 4 digits you would have You would have the month. Sorry, no, you would have. Sorry, the second will be the month. Sorry, the day, the month, the year. So this would be the sort of format that we will be parsing. And so if we want to look at the content of that particular data frame, there is this very useful method called print a schema, which will tell you, based on all the parsing that we did, what is the name of it and what sort of type is associated for what type that particular column has. And always it's good to know and check what is the content of our file and making sure that that makes sense. And again, remember that this display is particular to Databricks. If you don't have Databricks, you can do things like logs df.show, or you could do, let's do show. And then it would give you the exact same result, but it won't be as nice as the one provided by Databricks. So since we're going to use this this particular data frame often, it would be a good idea to cache it, and that's what this line is doing. Any questions until here? No questions. That's good. All right, so if we cache our data frame, that means that we load it in memory, and then in principle, we can do operations much faster.
Armando, there was a question in the chat.
Oh, I missed it, yep.
How to show the last 5 elements.
Okay,
I'm not sure. Does it mean like the last 5 rows?
Oh, so probably, yeah. So I think you can do tail, right?
Yeah.
Oh, tail. No. What is it?
Yep, tail 5 and.
Yeah, it didn't work. Tail data frame object has an attribute tail.
Let me check.
Show data frame. So let's look at data frame. Data frame. And let's look at show. Show, truncate. I wonder if you do show minus. Show minus 5. Yeah, that might be it. So you do, oh no, that doesn't work.
I think you can sort them and then you can show the top like 5.
Yeah, that's a good point. Yeah, you can sort by.
Sort in descending order and then show the 5 rows.
Yeah, that is a good trick. So we do sort, and then we sort by logs df dot time, and then we do it in descending order, and then we show. Yeah, that would work. That seems to be doing it. So that's a very good trick. If we then don't do this, so so now the first element is August 1st, and then when I do descending order, it would be forget the syntax. Would be August 22nd, right? So that's a very good observation. Thank you. I'm pretty sure. I think tail is in pandas data frames.
You can use head command in this one.
Yeah, let's see what does what head does. If we do head, yeah, so it just shows the first one. So,
yeah, head is the first as well as first. So head, you can give a number, how many of the head you want. It's like top.
yeah, yeah. So head, and then so we do 5. And they will show, yes, the exact elements. But can you do negative? What happened here? No. Let's see. Head. Returns the first n rows. So yeah, I guess you would have to sort it if you want to do the reverse or take the last few elements. You would have to sort it first. All right, good. Show. All right, so we are now on part 3, which I think still we haven't actually started the lab, all the exercises. This is sort of like warm up, getting you used to the different options available for data frames. So one of them that could be useful is describe. And why is that useful is because it would give you access to some of the statistics available. And then if we have here are the right, calculates the count, mean, standard deviation, mean, and max. And then of course, if you don't give a column, then it will calculate the statistics for all the columns. I think, yeah, let's see if this works.
So just going back to what you can do to get the data, you can actually convert the data frame to RDD.
Mm-hmm.
It was what we used last time, like we take ordered.
Yes.
And then you can convert it back.
Yeah, that's true. That's that in a way is doing the exact same thing of sorting the data frame by a column and then show. Yeah, that's a good idea too. Thank you. So describe could be useful in the initial stage of your data exploration, but remember that you can chain operations. So let's say that you want to apply some other things like a filter of some sort, and then here let's say status equals 200. I don't know if this is gonna work. Yes. Oh, equal. Actually, I think it gives the same result. But the point being that you could chain many different operations and then do a describe. This would give you some summary statistics that then you could use for deciding whether this particular filter would be useful, or at least to have some idea of what your data set is doing. 94,000. Yeah, there's many more. Okay. There's also many different SQL functions available. And then for the full list, you can go to the API. Where did it go? So if we do SQL functions, SQL functions. Okay, Spark SQL. There we go. And then functions. Yeah. So here the full list of the functions. So many of them are typical mathematical functions that you could do operations. There are other ones for sorting. and I think we will use some of them. You calculate correlations between two columns. So in a way, when you're doing this particular import, you would have access to all of them. And these are the functions that are, most of them are available, or they're inspired in the functions available in SQL. So let's see what we're doing here. Content size stats. Right. So do you remember that we used the described in to obtain the statistics of the data frame? So this is doing sort of like the same functionality, but I guess the point being that you can use SQL functions on particular columns to get results. All right. The next one, we'll look at the status values that appear in the log, and we want to we start with the logs data frame and group by the status and then count. So so the status is one of the columns. Then we count those status. So that is a way of doing the aggregation. So for each one of the groups, we'll count how many in the group there are, and then we would sort by that count. So then this would tell you for each status how many rows you have available, and so this is telling us that the most common status is 200. So that's bad request, right? And then some more exploration. You guys have done some HD. Sorry. So, oh no, sorry, 200 means okay. So the status code 200 means that most of the requests, the fact that most of them are 200, that is, I guess, a good thing.
Armando, there's another question about the group by from the group asking about group by.
Oh, I better put this here.
Data frame versus RDD. So there was a question we discussed not to use group by key in RDD.
Yes.
Which is correct, but the same issue does not exist in data frame. So it is safe to use group by in data frame, and it will actually perform quite fast.
Right. I mean, you're certainly more experienced in that. Do you mind giving us some insight of why is that the case for data frames and not RDDs?
Yeah. So the problem with data frames and RDDs is how they actually perform it. So what they do with RDD group by is that they create a huge linked list, and they append that linked list into memory, and then you perform your operation on that linked list. And a data frame group by does not do anything. A data frame group by just lets you know that you're going to perform in some like a reduce by key on the functions that are going to come after the group by.
Oh.
So when you do data frame group by, it doesn't do anything, just says, hey, by the way, I'm going to be summing the next functions by these keys. Okay, so that's the big difference. It's not actually, and if you look what's returned from it, it's returns like a group by element that all you can do is apply the aggregation functions to it.
Right. Okay. Yes, that makes sense. That makes sense because there are optimizations that are done at the data frame level, correct? Is that what
Yeah,
you?
so exactly. So the optimization, the parsing of the actual execution plan is done at the end, and it removes it. So it doesn't actually create anything like it would with a group by key in RDD.
Yes, exactly. Good, thank you. The next thing is to showcase the display function of at Databricks. Sorry. So at this point, you guys are familiar with it. You can actually, by default, just displays the table, but you can also look at it from, say, a histogram perspective. So in a way, this is saying the same story that group by we did. And then after count, that's what a histogram is. And then this is not a very effective plot because the 200 codes are all together, and that is because of the bin size. So I think the suggestion is to then do a transformation, some sort of log scale, log scale transformation. So there is this functional, or this helper function called prepare subplot, that what it does is it makes the plots look pretty. But in case that you don't have it, I made some modifications to the notebook in case that fail and you feel like you don't want to install it. You can also make it work. In fact, half of the solutions I made it without it, and it worked fine. So if you don't install it, then in a way you would have to split or explicitly say to import NumPy, matplotlib, etc. But if not, there are aliases for them in this Spark notebook helper library, which is a Databricks library. And I think somebody asked what is the license, and it is I think it's under Creative Commons, which means that you can use it not for commercial uses. So if we then go there, and I think at some point some of the versions of the notebook had something different here for the figure and the axis, but what it's doing is preparing those figure and those axes, so it would pass the proper ranges to make the plots look pretty. Ooh, log status count not defined. Why did I miss that? Oh, I didn't run this. Right. So this is another very useful function, with column, and what it does, it creates a new data frame with the column name as the third parameter, and then whatever transformation you apply to another column, the result of that will be stored in this new column. So if we were to display the values, or display this particular data frame, you contain the status, which would be our key, the count, and then the log of that. So I think this with column, I used it several times to do some of the operations requested in the exercises of the lab. All right, so let's run that. And then in principle, now what we'll see is that the 200 codes would be separated. So we would have the 200, 302, 304, etc. And then this plot might not look as pretty as the one that you would get if you have the prepare subplot in here. But it still is readable. It does what it's supposed to.
Sorry, Armando, can you explain what this zip function is doing?
Which function, sorry?
Zip.
Oh, zip. So zip is a Python function, and what it does is, let's say that you have two lists, and they are of the same size. What it does is it takes the first element of the first list and the first element of the second list and converts it into a tuple. and then and so on for all the elements of both lists. But when you have, I think you're asking where was that? Here. But when you do it in the reverse way, like when you do the when you add the star before this tuple. So this one in particular is a list of tuples. So this log status to count df is this data frame that we had here. So we are taking this last column, and we are we are dropping the count column. So therefore that would give us the status and the log count column. And then if we collect that, that would give that would have a list of tuples. So if we look at the content of that, so this is something that you could always do if you don't know, if you try to figure what exactly it's doing. So you see, this is a list of rows. So remember that zip, what it does, it just takes two lists and zips them, or two objects and zips them as tuples. And then with this, you are unzipping them. So this will then be unpacked into two objects, X and Y. So the X would contain all the statuses, and then the Y contain the log count.
Right.
All right. Let's see. I think I still so far everything is being sort of done for you. So until this point, everybody should have gotten all the same answers. So in this one here, frequent host. So we have logs df, and usually sometimes you might get lost and you don't know exactly what sort of transformations you're at this point. So my advice is do what I did what I did in the previous example here, where if I want to explore what this particular zip function does, I look at what data contains, and that might give you an idea. And then you could use display a particular object, and that can give you a hint of what's going on. So the first one is the data frame, the initial data frame that we have already been playing with so far. And so if we group by the host, this particular one will return for each one of those hosts how many entries we have. And the next line would filter those hosts for which the count, which is a column that would result from this group by, or the aggregation on this group by, is greater than 10. And then because this is a data frame, we can do select, and what we're saying is select this particular column, and then we show those we show those values. So let's say what happened if we don't do select. So just as an example, if we don't do select, then of course we will print the whole data frame. We will show the whole data frame, and in this case the data frame just contains one extra column, but this is just to show a way of doing. But actually, the beauty of this sort of thing is that you can do, there are many ways of doing it. You could actually do select of host. That is exactly equivalent to doing this. So this is, I guess, just syntax, like easy to write and read syntax. But actually, this is way more explicit. And I think when you're writing code that you are going to access maybe later, or somebody else might be accessing later, if maybe it's better to write it in an explicit way rather than this one. But in this case, it's a simple data frame, so it will make no difference one way or the other.
Armando, just
yes,
one quick comment. For if you're only going to work with one data frame, then you can use the short form. But the other method, you will need to use it once you start joining data frames. So you need to know which columns from which data frame. That's where you want to be more explicit and be more clear about where things are coming from.
Yeah, yeah, thank you. That's a very good comment. Yeah, we'll see some use of that later down in some of the cells. But yeah, absolutely. Thank you. Now let's visualize the number of URIs in the log. And so we started with this initial data frame. We group by the path, aggregate, count, and sort. So I don't think there was anything to do at this point yet. So just doing exactly what the instructions say, group by the path, count how many of them there are, and then we sort by the column count, which is created when you perform the aggregation. And I think this was the one that was creating the confusion. So up to this point, we have a data frame. This data frame, if we want to do map, we would have to first convert it to an RDD. And why we do this map is that so when we do collect, which is we could in principle map the two columns into a tuple, where the first element of the tuple will correspond to the path and the second one would correspond to the count. And then after we do that, we can do exactly the same zip of this particular object that contains the tuple, contains the list of tuples. So we can do the plot. So I think that might have created some confusion, or that for sure created some confusion, because at some point one version of the notebook didn't contain this line. So then of course map would have failed because it was trying to operate into a data frame.
Excuse me, Armando.
Yes.
Why is it not possible just to do paths df.select, paths df.collect, and not bother with everything else?
Well, yeah, good question. Let's try it out and see what happens. So add cell above. So if we do this, so let's just give.
You don't even need to select because your data frame already contains path and count. So
yeah, I mean, also this is for illustrative purposes, right? So make sure that we follow exactly. So the select is not required, but it's to show. If you notice, this is the first time that we use select in a multi-column. So just to show that you can actually pass multiple columns. So in this case, would give the same thing. And then if we do collect, yeah, that would work too. Let's see in 1 second. I want to see add cell above. What is the type of this? MBF.
Yeah. So Armando, the difference.
Yes.
The difference between doing it with an RDD and not an RDD is that when you do a collect on a data frame, it will return a collection of the row object. And what you do with the RDD maps is you're converting it to the actual tuple. But I think what we saw before is that maybe the Python zip is able to break up that row element as well. So
yeah. So let's
even
see.
though it's not true tuple but a row object.
You're right. Yeah. Let's see if this works. So something like this, right? Yeah, that will do the same. So that in principle should give the same plot as the other one. Add cell below. Right. So it is true that it's not necessary the result would be the same, but the object is an object row, and then the zip can break it or can unpack it. But yeah, the result is the same in this particular case. I don't know if there is another insight that you might want to share, Eyal, now related to this.
What I did when I when I was solving my things, and just to make things easy, and you use the zip in the other remaining of the lab, they were looking to get a list. So I just did an RDD map and collect to get a list of that one element, which I found to me was easier than to try to write something that's more complex.
Oh, you're saying without the zip, but directly once the
So what you can do is without the zip, so you can say path is.
Yeah, I see. So let's that's a good let's write it here at cell above. So you can do paths equals to paths, and then select path. Is that what you're saying? And then
yeah. So no. So what I did is RDD map to x to x to x lambda x to
yeah, that works too, right? Lambda x to x, yeah.
Yeah, and then collect. This will give you x x0 actually, which means the first element in the path.
The first element in the path.
So it needs to
right, because this is a row.
Yeah.
Right, this is a row, so we want to get the first element of the row.
Yeah. So that's the way I did it. And if you want the second element, you remove the select, and you can say first element or second element, or just put the name there.
Oh, are you suggesting this? Oh, I see. So instead of path, I see what you're saying. So for count, right? Because the other one is count.
Yeah.
Like this.
Yeah. So what you can do is actually remove the select count altogether.
Yes.
And then just do an RDD map and then say X1, and we'll give you the first. And if I'm not mistaken, if you put in a brackets count, it will also work. Instead of 1, do it the name count. Yeah. Try that. I think that would also work.
Yeah. Okay.
So those are options. If you just want to get a list, instead of going through the zip, you can do something like that.
Yeah. That is very useful, and I think this is great because it showed us another way to accessing RDDs by names, right? But if you notice, all this that you had to do, if you want to select a particular column, is just already done for you, or it's easier to do if you have a data frame. So this is a very good.
I think the lambda function will do an extra work there. So instead of that, we can use the select, because select will just select that particular column.
Yes, exactly. This is doing somewhat extra work, right? But this is effectively what the select is doing. Yes.
Excuse me, I have a question regarding the performance. So when we convert the data frame to RDD, is it something happening underneath in terms of, is there any performance difference between two approaches you just came up with?
Yeah. So when you convert a data frame to RDD, there is a conversion cost because you actually need to instantiate the objects. Okay, so it may be that it will do it for you and it's not going to be a big hit, but the data frame itself does not reside in memory the same way an RDD is.
Right.
Okay, because an RDD is stored on heap and a data frame is stored off heap.
Oh, okay. I see. I see.
So it needs to bring it out from the off heap into the on heap in order to perform things on the RDD. But it will do it as needed.
Oh,
So it's actually it can work okay, but there is some conversion hit to it.
okay. Okay, I see. Thank you.
Yeah, thank you. All right, and then I guess this is just to show that you can. I don't know. Yeah, this is sort of like repeating the same stuff. All right. And how are we doing? Okay. So then if we want to look at the top paths, then well, we already have this paths data frame, and again, if at this point you might have forgotten, you can do display of paths, and then you see what the structure of that is. And this particular one is already sorted because we did sort it before. So then we if we want to get the top paths, we won't necessarily have to resort it. Okay, now we start getting into the interesting territory. So the first one is to get the top 10 error paths. So just because I just realized that it's almost 8, I'm gonna try to speed up a little bit here. So the idea would be, of course, to do a filter, and then you filter this particular column, being that this particular column is different than 200, and we would select the column paths, and then for the next one, if we want to, oops. Oh, I see what is missing. So we already have this data frame that is actually of one column and contains those entries that are not 200. So we group by that path, which is the only column, and then we count how many of them would be. The resulting data frame would have 2 columns, one for each path, and then the count. And if we want to sort it, we can sort it by accessing or by passing the key ascending. All right, that looks good. Any questions for this one? No questions. That is good. So then, because it's already sorted, we see that this particular column, this count column, is descending.
There was one question on the chat about the fact that select is not necessarily required. That is correct. You don't have to do the select there to limit it to only one column. You can keep it all of them, and then the count will be will eliminate only keep the group by and the count fields.
Yes, that is correct. Yeah. Thank you. I mean, yeah, we could just quickly see it here. If we remove this here, that should give us the exact same result. Yeah. There, exactly. All right. So then this should pass the test. And then we go into the number of unique hosts. So at this point, we can do the following. We already, starting from the logs.df, we can select the host, so the column host, and then we call distinct on it. And then what this would do, it would only leave one record per each one of the groups. Each one would live only the distinct records. And I think for this one, there might be other ways of doing it. You could, I guess, I mean, you can make it even more complicated. You could just group by the host, and then do some simple operation, then take the column. That would also guarantee that that you would get the distincts, but it will be much more convoluted way of doing it. All right. Any questions until here? Oh, I think there was a question. Sorry if I'm not following much the chat, but I think there was a question. How can you aggregate results as a new column to the original data frame? For example, you can group by. Oh, you can join back. So that would be one way. So in this case, unique host, if we look at the content of this particular data frame, add cell below. I should do display. Display. Oh, cannot call. What? Oh, right. Yeah, sorry. So let's say that we don't do, because I did a count here, right? Let's say that you do have a data frame that contains something similar to what we had here. Let's say this one here, where you have the path and you have the count. So you would have to group by, and then in this case, join. You would have to have the original data frame and join with this new data frame on the key being the path. That would be the way of me doing that. So the question was, if I do a group by, how do I join, or how do I put this back into the original data frame as a new column? And the answer, or the way I would do it, would be to join the original data frame with this new data frame on path, on the column path.
So,
yeah,
Armando, there's actually one other way that you can do that leverages SQL, and you can actually perform what's called window functions.
Okay, yes.
So you can say, I want, when I'm selecting my thing, give me my previous record data, or I want to see my aggregation over a certain window that I define based on my current location. So things like, creating row numbers or things like that. That could be another way that you can add it, and it would be a bit more performant than doing the joining itself.
Yes, thank you. That is a very good point. I think at some point we'll try to get some window functions, which can always come handy. All right, so now we want to count the number of daily hosts. This particular data set is only of 1 month, I think the month of August, yes. So we don't have to do, is that it? Day is the day of the month, and count the unique hosts per day, yes. So there would be that we can use the SQL function called day of the month to obtain that, or to add that particular new column, and then you can do it in the following way. We can select the host. So this is another way of doing the select. So remember that at some point we did select with the actual string or the name of the column. We also did log df and then square brackets host. Those are all equivalent. And then in here we are doing another new column. In this case, a column based on another column. So we pass a function. So this function, the SQL function day of month, on the column time, and by then doing alias. So this alias is a method of column. We would rename that column day, which would give us the number of day. Then what we can do is remove duplicates from that particular data frame, because we're interested only in the unique days. And then we can then group by the days and count. This alias is not necessary here, actually. And we sort by the day. So let's see what that looks like. So let's see if we actually remove this alias, that should give us the same result. Yeah, that is not necessary. So I think it's just confusing. So what we created was a new data frame, and we added a new column that contained the day number, and then we group by each one of those days, and then count how many entries were per day. And so if you want to visualize that, what we would do is somewhat similar to the unpacking that we did. So I think this particular example in a way is repeated a few times, that you unpack values for display purposes. So this is one way of doing it. I will show another way later down. But what you could do is initialize a list, and this particular data frame. This is again, if we forget what it is, let's look what it is. Cell above, display. This one would contain the day and the count, so that is what we just calculated. So then when we loop over this particular collection, it would have two elements. The first element would be the day, and the second element would be the count. So in here, for this particular list, days with host, we're appending the first element of the first tuple element. And for host, the host list that is defined here, we append the second element of the tuple. So that's one way of doing it, but there are many ways of doing it. I'm sure you guys came out with some other ways, and I'll show another way later down, because we repeat this process. So in here, actually, I use the prepare subplot helper function. So you would pass two things. You would pass to list, so the range of elements for X and Y, and what it does is just makes the plot look pretty. And the core part of this of all this codes is here. When we pass to matplotlib, or we tell matplotlib to create a plot where the X is the days with host and the Y is the host, so the counts for each day. And then we see that there might be some sort of pattern here. Maybe this is, this looks like it happens every 7 days or so. So that's probably a pattern that repeats every week. But then, of course, you could do it also with data frames, with Databricks. And you can do, in this case, a line plot, and they should look very much the same.
Armando, just a quick question about the Databricks one. Can you make them start from 0, the axis?
Good question. I don't know. Let's figure it out. I don't think so. Yeah, not that I know. So that's why, yeah. I mean, this is very good, because it makes things sort of automatic for you, but at the same time, it makes choices. So it chooses the particular ranges to be between 25 and 4,500. But yeah, I don't think you can
Yeah, and statistically, that's a big no-no to have your graph not start at 0.
Yeah, I mean,
It can be misleading.
Yeah, of course. I mean, they say, "Oh, look how much variation there is," but at the same time, yeah, here, if you start, so it goes from 0 to 5,000 in steps of 1,000. Yeah, that could be misleading. I agree with you. So yeah, all right. Then the next exercise is calculating the average number of daily requests per host. Let's see. Oh, this one can get a little bit tricky. So let's see if I'm gonna copy the text that I have just for in favor of time, but then we can go over the solution. So we had logsdfs, and logsdf is the data frame, our initial data frame that contains all the columns, host, path, status, etc. And then we're interested in the day of the month. We are interested, day of the month. And that is a function that we would apply to the column time. And we would call that column day. And if we group by day and perform a count, this particular, up to here, total requests per day, it would give us, well, what the name says. And then if we have that, we can change, say, this in this example, what is showing that you can rename the column. So in this case, we had the column count, and we are renaming it total. But in principle, this is the exact thing you want. Now, there is the other data frame, total requests per day. So total requests per day, so let's just, total requests per day is the one that we just created here. And we would join that back with the daily host df, and then we join it on the key day. So in this case, daily host ds is a data frame that we created that has two columns. The first column is day, and then on the second column is count. So there is that day key that those two data frames share. And then, so if we want to create the total count, so at this point, maybe we should do something. Let's do the following, just so people can follow. Let's just comment all this here. If you look at what the frame contains there, it contains 3 columns, right? The first column is total, and why we renamed that column total is because when you do the aggregation, you would get another column count, and that would not be good. You want to have 2 different columns. And what we're interested is for each day, calculate the ratio of total over count. And that's what we'll do in the next lines. But again, if you have a hard time following exactly what you're doing, I think it's a good idea to do little data exploration, so looking at your data, so you know exactly what sort of process you're following.
Armando.
Yes.
Just a quick thing. This is all, this is, as we say, for education, and we show people how to do joins and whatnot. But this is completely unnecessary, for sure.
Yes.
We can actually call the average function directly.
Yes.
and have that do all that calculation. I'm just letting people know not to expect that to be the method of what they need to do in those situations.
Correct. Yes. No, I agree. Yes, absolutely. So in this case, we have we had this particular data frame that contains the 3 columns, and what we're doing is we aggregating a new column. In this case, we call it some name, average request per host per day, and the content of that column would be the ratio of 2 other columns, which are specified here. And we sort by day, so we keep some consistency, and then we cache that particular data frame. So if we were to look at it now, it would have those initial 2 columns that we had up to that point, and then the 3rd column, which is the ratio of the previous 2. And I think that was, I think somebody had a question at the beginning related to this point. So yes, this particular one, it is unpacking this row and then making sure that the values are whatever integer values you had. So if at this point is not clear why this particular approach works, and I think the confusion might have been because there was a transformation done to or transformation from data frame to RDD, then let's talk about it after. All right. Visualizing the average daily request, per unique host. All right. Any questions until here? We're all good.
Amanda, could you show us how to use the average function to implement the?
Oh, yes, I can. You know what? Just because it's well past 8, which is the end of the session, I'm gonna send that in the solution. How about that?
Oh, that's great.
I'll add it to the solution so you can see it. Okay, so we are for F. So we are visualizing this particular data frame that we generated. So I'm just gonna follow the same approach that we had before. Notice that in this case, this is all Python. So this is the SAC. It would mean the same as if you do this list, right? So it just follows the exact same approach. So I'm not gonna explain it because it's what we already explained before. And that looks good. And then the plots, oops, yeah, that looks good. And then if we want to use the one for data frame for Databricks, we simply enter the data frame that we define. And then by default, it shows the table. But in this case, if we want to show the line, we do that, and it will pick it up. And then again, it just chooses the range. So yeah, this looks like there's less variance here, but actually it's just the exact same data. All right, exploring for codes. So typically, when you're doing some sort of analysis, you might be interested in looking on a particular subsection of your data. So in this case, you want to know what those 404 codes are, because 404, the 404 code means that it was not found. That was the response by from the server. So how do we get the 404 codes, given that one of the columns of them is the status? Well, we would filter by that column. So that is one way of doing it. Similar, the syntax, or very similar syntax, you could do the following. You could do status equal 404. So actually, these two are just equivalent to each other, but I'm just showing different ways of doing the same filter. And code records. Using the data frame containing the 404, print out a list up to 4 distinct records. So if we are interested in printing, so I'm gonna comment this out. So the first one, we select, we're selecting path. And then on the second one, we select, oh, this is actually the same. This is just two ways of doing the exact same thing. So just, yeah. Oh, no. Oh, yes. So these are they're not found. And then the next one is, because we are only interested in the distinct, that's what this distinct we do. So somewhat repetition of the same sort of methods that we used before. This for sure is going to pass. And 5C, listing the top 24 for code paths. Code paths. Any questions until here? Are we good? All right. So this is in a way repetition of what you guys have seen. If we have this data frame that contains the column path, we can group by it, count, and then sort by that count. And then because we're interested in the top 20 of them, we can sort by it and then show only the first 20. And I think that's exactly what this is expecting. So that would pass. And then, and then now that we already did something for the paths, well, listen to the top 20 response code host. So now, very similar. So in here, what we did for the previous one was to group by the path and then count. If we're interested in do the same thing for the host, we will group by the host and then count. So very similar. And then on the next one, this is 5E. Listen the 404 errors per day. So at this point, we're familiar with the SQL function day of the month, which would take a timestamp and would give you back the day of the month. And then we will sort by day. And I don't think there's nothing new here. There is no new learnings here. This we already did all this in detail. So I'm gonna go forward. And visualizing the 404 errors by day. I think this is where I do it differently. Yeah. So remember that in the previous one, we did this for loop, but there are other ways of doing it. You could, for instance, select the particular day that you're interested, the particular column that you're interested, convert that to an RDD, and do a flat map of that RDD, and then you would collect it. So this is somewhat similar to what AL was suggesting or suggested earlier on, where we did the RDD, and then we map each one of the elements. Actually, yeah, that's a good question. I think in the other solution we had a map, not a flat map, right? So we do map here. Oh, why is this? Let me think about it. Everybody following up to this point? All good? All good so far? I know went a little bit faster now, but I think all the topics we had covered in detail at the beginning. Questions? Hello?
I have a question.
Yes.
Can you go to 2D?
2D, all right. Here we are. Ooh. Went too fast. Should I use the search? Did I pass it? To the year. Yes.
Can you explain the syntax, like this star expressions? What is this syntax? Aggregate star expressions.
Oh, yes. So this is similar to what we did when we looked at the zip, right? So expressions at this point is a list, right? So look what this for is doing. What this for is doing is going over each one of the columns. So the columns in this case are host, timestamp, path, status, and content size. And this expression is just a Python object. This has nothing to do with Spark. And when we call append on a list, what it does is just adds the element on to that list. So if you, at this point, if you look at the content of expression, that's about, right? Where's Candle?
I think you have already executed the expression, so you have some value in that.
Yes, yes, yes. So exactly. So no, but there is exactly. So there was the function called count null that would take a column name, which is what we were looping over, and then we'll return so this is null, which return an integer, sorry, a boolean, and then you would transform into an integer, so 1 or zeros, and then you would put it back the name of that column there. To the, yes, exactly.
So essentially, you are collecting all the columns in the expression, and then you are passing that as a, like, in one shot.
Yes. Yes, because we're counting exactly. We're counting how many null values there are in each one of the columns. Where is it? Here. 2D. And then what this star is doing is unpacking that that list. Okay, thank you. If you have more questions, we can do it after as well. You can ask on the Slack channel if it wasn't clear enough. 5G. Oh, so yeah, we finished this, and then we display it. We do the plots of that. Yeah, that looks good. And then the same thing for data breaks. And then 5G. Oops. Using the data frame errors by date sorted, you can catch the 5E. What are the top 5 days for 404 errors and the corresponding 404 errors? So this would be just sorting this particular data frame that we already had. And then this should give you the right result. Yep, all good. I think at this point, maybe we should stop just because we're getting to 8:30. I will. I think we just have a few things left. I'm going to put here my solution. So I will share this solution so you guys can follow. And if you have questions, make sure to come back and ask. But in this particular one, the idea would be to find the hour with the most entries. And why that's important? Well, you want to know what time particular errors or particular response codes are more frequent. So you might be able to either do something on your server side or find ways to, if it's something you don't like, find ways to improve or stop particular codes. Yeah, I don't think there's any groundbreaking things up to this point. So for next week, there will be another lab, and we will release the material. We'll release the material soon. I think tomorrow. And the reason for that is that we will wait everybody to submit their solution today, so we can do the material and the grading assignment in one shot. So this is the for the attendance. If you want to enter your email address, make sure you fill in this particular Google form. I will remove or I will stop accepting responses after the
It is not responding.
Okay, it's not accepting response. So just give me 1 second. Copy. And yeah, that was quick. So and okay, so can you please try again? Let's see.
The same link?
Yeah, same link. Same link. Yeah, it is working.
Right.
Yeah. So thank you all.
Hey, Amanda, before you go, I have a question. I use a different email address for registration.
Yes.
But now for the Google groups, like you can access only if you have your Gmail registered.
Oh,
so how
yes.
can I change my email address?
Can you please email Merdad? He would have or email Merdad and I, and we'll figure it out.
Okay, all right.
Yeah,
Thank you.
So okay. Well, yeah. Thank you, everyone, and we'll see you next week.
Can you put the attendance link in the chat?
Yeah, I'll do that right away.
Armando, quick question. Next week was supposed to be an on-site, and I saw that it was changed to an online.
Yes. So there were some. We had some trouble with the schedule, so we had to move the live session for the week after that. So apologizes if people had already planned around it. But yeah, we had some issues while scheduling. So it would be a virtual session instead.
Okay, and the following week will be the live one.
Yes, we will confirm. But I mean, at this point, that's how it's looking. I don't think it will change, but yeah, we'll working at it.
Okay, just wanted to confirm because it was initially said
Yes.
otherwise.
Yes. Thank you. Thank you for noticing that.
Okay, thank you. It was a great session as always.
Yeah. Thank you, guys. All right. Yeah, so I think Diego, I was asking if there's a better solution for the join. Yeah, that was related to the average. Yeah, we'll send the answer, or I'll add it to my solution before I publish it. All right, thank you everyone, and we'll see you next week. Bye bye.